Yes, everyone, welcome back to the next video in the GCSE math series where you're going to learn everything you need to know to get that grade 9 in GCSE maths. Today we're looking at highest common factor and lowest common multiple, another easy topic to get marks on, I think, in the GCSE series. So yeah, let's get into it. We're going to master it, we're going to succeed, we're going to get this done. All right, let's go. First, okay, so we're going to be looking at, in today's video, we're going to look at the key concepts first. Then we're going to look at the finding prime factors of numbers. Then just look at highest common factor and lowest common multiple separately. And as always, there'll probably be a separate video on the exam style questions just to separate it out for you guys. So, a factor is a number which divides exactly into another number. So the example I've given you here is 12, and the factors of 12 would be 1, 2, 3, 4, 6, and 12. This is because each one is divisible by 12, and yeah, so that's it. You can see all the factors there. A multiple is a result of multiplying a number by a whole number. So the example I've given here is for the first few multiples of 5 are 5, 10, 15, 20, 25. For 6 it would be 6, 12, 18, etc. So a continuation of these definitions would be highest common factor. So the highest common factor of two or more numbers is the biggest number that divides into all of them exactly. So, for example, if I was to do 12 and 24, the highest common factor would be 12 because 12 times 1 is 12 and 12 times 2 is 24. That's the highest common factor they share. It's the highest number that divides exactly into both of them. Lowest common multiple of two or more numbers is the smallest number that is a multiple of them. So if I was to do 5 and 10, the lowest common multiple would be 5 because obviously 5 goes into 5 and 5 goes into 10. Very simple. Okay. Finding prime factors. So, to find prime factors, we need to make prime factor trees. And what this is basically a decomposition of each number, dividing the number by certain numbers and just creating these prime factor trees. So, looking at 28, we start off by going 28 like this, drawing two lines going down, and we break it up into two numbers that times together to get to 28. So these can be 14 and 2, 7 and 4, whatever you want to go with. I'm going to go with 14 and 2. And what we see here is that 2 is a prime number. So what we do, we circle it there. Then we can break this into 7 and 2. This becomes two prime numbers. So these are no longer divisible by anything. 7 and 2, nothing can be divided by these numbers. So we write the prime factors as 2 times 2 times 7, or 2 squared times 7. Right, like that. 1, 4, 4. Creating a prime factor tree for this one. We can break this up into 12 and 12. Both these numbers can be divided, so I'd go 4 and 3. You could also do 6 and 2 there. 3 is a prime number, so we circle that, and then 2 and 2 and 2 and 2. Therefore, we can write this as 3 times 3 times 2 times 2 times 2 times 2, or we can write it as 2 to the 4 times 3 to the 2. Looking at 2, 5, 6, we can do this as this one's gonna take a bit of thought. 2, 5, 6. What is numbers divided by 2, 5, 6 divided by 2? 2, 5, 6 divided by 2 is 1, 2, 1, 1, 2, 8. 1, 2, 8 divided by 2 is 64. 64 and 2. Then we could divide this into 4 and 16. No, we can't. We can do this into 2 and 32. 16 and 2. 4. Let's continue this here. 16 goes into 4 and 4. Then 2, 2, 2, and 2. So this is 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8. 2 to the power of 8. And that is how we do our prime factor trees. Okay, so to find the highest common factor of two numbers, what we have to do is conduct two individual prime factor trees. So, and find out the prime numbers, the prime factors. So you can go this into 12 and 2, this into 4, 3, this into 2 and 2. This one goes into 6 and 6, then 3 and 2, 3 and 2. And then we do a Venn diagram like this. Say 24, 36, and we plot a Venn diagram of these numbers. So we look at the common ones. So we've got 2 and 2, so we can put 2 in the middle here. 3 and 3, we can put 3 in the middle here. We've got 2 and 2 here, so we can put another 2 in the middle here. Then looking at 24, we have another 2, but there's not 2 on this side to match, so we can't put in the middle. We've got 36 and put a 3 there. And to work out highest common factor, we do all the intersection numbers times together. So the highest common factor in this case would be 2 times 3 times 2, which is equal to 12. So the highest common factor of these two is 12. And obviously you can see 12 times 2 is 24, 12 times 3 is 36, so that we know would probably make sense. Let's make some space to answer the next question. The highest common factor of 60 and 72, we use the same method, so I'll break this into 6 and 10, 3 and 2, 5 and 2. Then we've got 12 and 6, 6 and 2, 3 and 2, 3 and 2. And these are all our prime factors. Like that. Once again, we plot our Venn diagram like this. 60, 72. And we go 3 is common here and 3 is common here. Put 3 in the middle. 2 is common here, 2 is common here. Put it in there. 5 is only exclusive to 60 and not to 72, so we put 5 in this side. Take that off. 2 is common in both once again. Put 2 in the middle here. 2 and 2. And then there's obviously no more factors left on the 60 side, so everything else will just fall into 72, so 3 and 2. So the highest common factor is 3 times 2 times 2, which is equal to 12 again. Which obviously makes sense because 12 times 5 is 60 and 12 times 6 is 72. Okay. Now, looking at the lowest common multiples, we do the exact same thing. We go 36, break this into 6 and 6, break this into 3 and 2 twice. Then we have 48, break this into 12 and 4, break this into 4 and 3, break that into 2 and 2, and then 2 and 2, like this. And we see these are all our prime factors that we need to know. Do our Venn diagram. And then we have our 3 is common here and here. So put 3 in the middle there. 2 is common here, 2 is common there. So put 2 in the middle here. 3 is exclusive. The second 3 is exclusive to 36. So put 3 there. Tick that off. 2 is common here, 2 is common here. Put 2 in the middle there. Then everything else, obviously this side is 36 is no more prime factors, so everything else will just belong to 48. So 2 and 2. And the way we work out lowest common multiple is to times together all the numbers in the Venn diagram. Hence, the lowest common multiple in this case is 3 times 3 times 2 times 2 times 2 times 2, which is equal to 9 times 3 times 9. 3 times 3 is 9, times 2 is 18, times 2 is 36, times 2 is 72, times 2 is 144. So the lowest common multiple between these two is 144. Moving on to the next one, we can find. Okay, let me just make some space. Get a bigger rubber. Okay. Exact same method. 80 gets broken down into 8 and 10. Break this down into 4 and 2. Break this into 2 and 2. Then go 5 and 2. These are our prime factors for 80. Then go 124. Break this into 62 and 2. Break this into 31 and 2. Right? Yep. 31's a prime number. 2, 2. So the lowest common multiple would be done by doing the Venn diagram method again. We have 80, we have 124. So we look at 2 is common here, 2 is common here, put 2 in the middle. These intersections get smaller every time, don't they? I'm flipping out. 2 and 2 is common here, so put 2 in the middle there. And then I can see that 31's the only one left for 124, so 31, put it here. And then, okay, everything else just will belong to 80, so 2, 5, and 2. So the lowest common multiple in this case would be 2 times 5 times 2 times 2 times 2 times 31, which is equal to 10 times 2 is 20 times 2 is 40 times 2 is 80. 80 times 31 is 2480. So that is our lowest common multiple. Lowest common multiple of 80 and 124. Yep. Okay, so I'll probably leave this video here and then continue with the exam style questions in the next episode. So I hope you guys enjoyed. See you next time.